angular displacement. Imagine a box on which a force is applied. The force F is applied to the right. The box under the action of force moves towards the right. Let the current position of the box be point A. After the force moves the box, it changes its position to point B. The box is said to be displaced from its initial position to a new position, and the box undergoes displacement. As the box moves in a straight line, it undergoes linear displacement. The word displacement can be divided into three parts, where dis means apart or away, place means a particular position, and ment means an action or a resulting state. So displacement is the action or resulting state of change in the particular position of a body, where displacement is a vector quantity represented by a small bold d or a small d with an arrowhead, and the SI unit of linear displacement is meters. Keeping in view this sample, consider a stone tied to a string and made to whirl. Force F turns the stone continuously to move it in a circular path. Initially, the stone is at rest. Let its initial position be point A. As the stone undergoes angular motion, as discussed in the previous video, it changes its position in a circular path by an angle from its initial position A. The final position of stone is point B. You can see that the stone changes its position at an angle, making an arc with initial position. The stone is said to be displaced at an angle, and it undergoes angular displacement. Like linear displacement is related to linear motion, angular displacement is related to angular motion. And like linear displacement, angular displacement is a vector quantity represented by delta theta with an arrowhead or bold theta, where delta is the change in the angle of the body at different positions and is equal to the final angle minus initial angle. The SI unit of angular displacement is radians. Angular displacement can also be measured in degrees and revolutions. In linear motion, the displacement is the measure of a straight line distance from initial to final position. Look, I don't mean to confuse it. Just take the same box and move it along the arc between point A and B. The box is displaced. Let the distance covered by the box be 10 meters. Is the displacement 10 meters too? No, it's not, because displacement is the measure of the straight line distance between 2 points. And in this case, displacement is 8 meters from point A. If another force to the right displaces the box to point A, then what will be its displacement? Yes, you are right. It will be 0, because there is no straight line distance between the initial and final position. Note that the total distance will be double of 10 meters. That is 20 meters, but displacement would be 0. With this point, we come to one of the most important mistakes people make when dealing with angular displacement. Let the stone undergo angular motion as discussed earlier. If initially it is at 0 degree and moves to a position of 30 degrees in a circle, then the angular displacement is 30 degrees. Where delta theta, which is the angular displacement, is equal to the final angle minus initial angle, that comes 30 degree. But if the stone moves twice in the circle, what is the displacement then? It is not 0, but 360 degrees plus 360 degrees, 720 degrees, as stone undergoes 2 revolutions or 4 pi radians. So angular displacement is defined as the angle through which a body revolves or rotates around fixed axis of rotation. It is represented by delta theta, which is change in angle and is a vector quantity. It is taken as positive if the rotation is anti-clockwise and negative if the rotation is clockwise. For example, consider the spinning motion of a top viewed from above. If the top rotates at an angle theta in anti-clockwise direction, then the angular displacement will be taken positive. And if it is moving in a clockwise direction, then it will be taken negative. This is arbitrary system assigned to use worldwide to avoid confusions. You can consider it opposite in your part of the world too. But if you needed guidance and you wanted to explain it to someone else online, that guy or gal would probably get confused. There is one last thing that we'll learn today. That is that angular displacement is an axial vector. Any vector which represents angular motion is an axial vector. Axial vectors get their name from the word axis, which means that they act along axis of rotation. Angular velocity and acceleration that we'll discuss in our future videos are also axial vectors. The direction of all these angular vectors is given by right-hand rule. Consider the angular motion of a stone. The angular motion in anti-clockwise direction. Curl your fingers of right hand in anti-clockwise direction, then the erect thumb will give the direction of angular displacement, that is upwards along axis of rotation. On the other hand, if it moves in clockwise direction, curl your fingers of right hand in clockwise direction, the erect thumb pointing downwards will give us the direction of angular displacement. I know it might sound confusing at first, but when you get to know different types of vectors and how their direction differs in the video mentioned in the tag, I am sure you will understand this concept better. Quiz. Consider the motion of a top. If it started at initial position A and rotated till it reached B, we want to find the magnitude of angular displacement if the top completes one revolution, considering B the initial point, and rotates through an angle of 75 degrees, till it reaches point C, which is the final point. What will be the direction of angular displacement if the top rotates clockwise? You know the drill. The answer to this question is in the description box below. But before checking, test yourself honestly. To memorize the concept of angular displacement permanently, just break two words that are angular displacement into root words, where dis means away or apart, place means a particular position, and ment means an action or a resulting state. And angular relates to angle. So angular displacement can be defined as the angle through which a body changes its position about a fixed axis of rotation. Remember that the A of angular corresponds to axial, which means angular displacement is an axial vector whose direction is given by the right-hand rule. Follow us on all our social media platforms. Thank you so much for watching this video. Like and subscribe for more such short and crisp educational videos. Smartitude. Learn fast, adapt well.